So now we will see some examples on multiple correlation coefficient. So our first example is condition for consistency of given total correlation coefficient. Condition for consistency for given total correlation coefficient is determinant of R is greater than or equal to 0. So how to prove this condition? We have R square 1.23 is less than or equal to 1. Since R 1.23 is less than 1, so its square must be less than or equal to 1. So by putting the value of R square 1.23, what is the value of R square 1.23 is R12 square plus R13 square minus 2 times R12, R13, R23 divided by 1 minus R23 square is less than or equal to 1. So R12 square plus R13 square minus 2 times R12, R13, R23 is less than or equal to 1 minus R23 square. So take all this quantity to right hand side. So 1 minus R23 square minus R12 square minus R13 square plus 2 times R12, R13, R23 greater than or equal to 0. This is nothing but a determinant of R. So determinant of R is greater than or equal to 0 is a condition, consistency condition for given total correlation coefficient. So we have proved this result. This is one of the result. Then we will move ahead to our next example. So our next example is if R1.23 is equal to 0, it does not imply R2.13 or R3.12 is not equal to 0. These both are not equal to 0. This is equal to 0. To prove this, we will take R12, R13 is equal to 0 and R23 is equal to 1 by 3. So what we have? So R1.23 is equal to R12 square plus R13 square minus 2 times R12, R13, R23 divided by 1 minus R23 square. So this is 0 plus 0 minus 0 divided by this quantity, and this whole term comes to be 0. So what we have, R1.23 is equal to 0. Now check what is R2.13. So R2.13 is given by R21 square, R23 square divided by R13 square. So R12 is 0 plus R13, R23 square is 1 by 3 square minus 2 into 0, this R12, R13 0 divided by 1 minus 1 by 9. So 1 by 9 divided by 8 by 9. This is 9 minus 1, 8 by 9. So what we have? 1 by 8. So no, this is 0. R13 is 0. So 1 minus 0. So it is 1. So this term is 1 by 9. So this is R square 1.23. So R2.13 is the square root of 1 by 9 and this is 1 by 3. So in case of R3.12 is nothing but square root of R13 square minus plus R23 square minus 2 times R12, R13, R23 divided by 1 minus R12 square. So this is R13 is 0, so 1 by 9 minus 0, this is 0, this is 1 by 9, this is 0 divided by 1 minus 0, and it comes out to be 1 by 3, which is not equal to 0. And r square 1.23 is not also, r2.13 is not equal to 0. So this is 0, but this is not 0. This is our proof of this result. Now we will move ahead to our next example. If x1 is equal to y1 plus y2, x2 is equal to y2 plus y3, and x3 is equal to y3 plus y1, and we have given y1, y2, y3 are uncorrelated with mean 1, mean 0, and standard deviation 1. So y1, y2, y3 are uncorrelated with mean 0 and standard deviation 1. We have to find multiple correlation coefficient between x1 on x2 and x3. Now we will find out. So to find out multiple correlation coefficient between x1 and e1.23. So what we have, formula r1.23 is equal to r12 square plus r13 square minus 2 times r12, r13, r23 divided by 1 minus r23 square. So we have to find r12. R12, before finding R12, I have to find covariance between x1 and x2. Covariance between x1 and x2 is covariance between y1 plus y2 and y2 plus y3. So this covariance can be obtained by just multiply y1 plus y2 into y2 plus y3. When there is product term, we will replace it by covariance, and when it is square, we will replace it by variance. So covariance y1, y2, first term is y1, y2, so it can be written as covariance of y1, y2 plus y1, y3, product term, so we will write this covariance of y1, y3 plus y2 square, so y2 square, so it is variance of y2, and plus covariance of y2, y3. Covariance between y1, y2, y1, y2, y3 are uncorrelated, so all these covariance are 0. But variance is 1, since standard deviation is 1. So this is 1. Similarly, we can prove that covariance between x2, x3 and covariance between x1 and x3 is 1. We have to just multiply, and when there is product term, we will write it as covariance, and there is square term, we will write it as variance. So in this way, we have derived the covariances. Covariances is 1. So now we will find the variance. Variance of y1 plus y2, which is equal to variance of y1 plus variance of y2. And there is no covariance, since this is y1 and y2 are uncorrelated, so covariance term is 0. So 1 plus 1, it is 2. Similarly, we can prove variance of, this is variance of x1. So variance of x2 and variance of x3 are 2. Similarly, we can prove that also. So now R12 is equal to covariance between x1 and x2 divided by square root of variance of x1 into variance of x2. So 1 upon 2 into 2, which is equal to 1 by 2. So R12 is 1 by 2. So similarly, R13 and R23 are also 1 by 2. We can prove it. So now we will replace correlation by 1 by 2. So 1 by 2 square plus 1 by 2 square minus 2 times 1 by 2 cube divided by 1 minus 1 by 2 square. So this is 1 by 4 plus 1 by 4, that is 2 by 4 minus 2 into 1 by 8 divided by 1 minus 1 by 4. So 2 by 4 minus 1 by 4 divided by 3 by 4. So which is nothing but 1 by 4 divided by 3 by 4, and it is 1 by 3. So this is a square term. So r1.23 is nothing but square root of 1 by 3. This is a expression for square, not for r1.23. So r1.23 is square root of 1 by 3. We have derived multiple correlation coefficients. Now we will go to another example. We have to prove r square 1.23 is equal to b12.3 into b21 plus b13.2 into b31. Now we will take its LHS. So b12.3 is minus sigma 1 upon sigma 2 r12 divided by r11. b21 is sigma 2 upon sigma 1 into r12 plus b13.2 is minus sigma 1 upon sigma 3 r13 divided by r11 into sigma 3 divided by sigma 1 into r13. So here sigma 1 sigma 2 get cancelled with sigma 2 by sigma 1. So we have minus r12 divided by r11 into r12 minus r13 into r13 divided by r11. So basically this denominator is same, so minus r12 into r12 minus r13 into r13 divided by r11. Now we will simply add minus r11 into 1 minus r12 r12 minus r13 r13 plus r11 into 1 divided by r11. We have added r11 and subtracted r11, so there is no difference in this equation. So this term represents, so it can be written as r11 minus, take outside, 1 into r11 plus r12 into r12 minus plus r13 into r13 divided by r11. So this term represents, so our r is 1 r12 r13 into r12 1 r23 r13 r23 1. So 1 into its cofactor r11, r12 into its cofactor r12, r13 into its cofactor r13. So this is nothing but, this represents determinant of r divided by r11. So this is 1 minus determinant of r divided by r11. So which is nothing but r square 1.23, and hence the proof. These are all examples related to multiple correlation coefficient. We will see more examples in coming lectures. Thank you.